So while solving MCQs related with the complexes with the coordination number 6 student, we all can use these tricks. If you are going to use these tricks, it will be easy for you to solve the MCQs. So what we have done, we have divided the electronic configuration of d orbital for the central metal atom into three parts. You can see this is the first part, this is the second part, and this is the third part. See, in the first part I have taken the configuration of central metal ion which is forming complex if it is D1, D2 and D3. Please remember D1, D2, D3 are actually indicating configuration of the central metal ion which is present in the complex. So for any complex, for coordination number 6, if the configuration is D1, D2, D3, then please remember always the hybridization will be D2sp3. And if D2sp3 means the inner d orbital involved for the hybridization, so that complex will be always inner orbital complex. When you say inner orbital complex, so the d orbital of penultimate shell is involved, and the magnetic moment for such complexes with the same configuration will be same even for strong field ligand and the weak field ligand. There is no need of pairing of the electrons. So even D1, D2, D3 is forming complex with a strong field ligand, there is no pairing of electrons because there are always two vacant d orbital is available. If you see the third part, if the metal ion is having configuration of D7, D8, D9 and D10. In the first part we had discussed D1, D2, D3. In the third part we are discussing D7, D8, D9 and D10. So in this case student, the hybridization for that metal ion in the complex will be always sp3d2. When you are saying sp3d2 means the outer d orbital involved for the hybridization. That's why this complex is referred as outer orbital complex. Outer orbital complex means the orbital of d orbital of the valence shell, that is indicated by N, is involved for the hybridization. Now again the same thing, magnetic properties for both, even for strong field ligand and weak field ligand, will be what? Same. So if it is D1, D2, D3, irrespective of the ligand, the hybridization will be D2sp3. And if it is D7, D8, D9, D10, so the hybridization will be what? sp3d2, and it is outer orbital complex. Please remember, in the third case, if these are the configuration, then even the complex is formed by strong field ligand student, there is no pairing of electron. Because even we are doing pairing of electron in case of D7, D8, D9, we are not getting two vacant orbital. So we take orbital only from the outer shell. So number of unpaired electron will remain same. Even if strong field ligand combines, there is no pairing of electrons. Now most difficult case that we have to remember is what? Part 2. This configuration is in between, if you will see, part 1 and part 3. Part 2 is D4, D5, D6. Whenever such type of configuration is present for the metal ion in the complex, then always hybridization and the magnetic properties are different, and that depends on the type of the ligand. If it is strong field ligand for such configuration, then please remember there should be pairing of electron to provide only two orbital, 2d orbital. So for strong field ligand, there has to be n-1 d orbital involved. Mostly it is involved from the third shell for 3d series elements. So since inner d orbital involved for the hybridization, then the hybridization will be D2sp3. Because of the pairing, the number of unpaired electron decreases. As the number of unpaired electron decreases, the value of the magnetic moment is less, and it forms low spin complex. If it is formed by weak field ligand, then The orbital is what? Nd. That is, orbital is taken from d orbital because weak field ligand does not cause pairing of the electrons. Mostly for first transition series element, this orbital is what? 4d. The hybridization is sp3d2. Here, the number of unpaired electron is more as compared to complex which is formed by strong field ligand. So the magnetic moment is comparatively more, and that's why it is referred as high spin complex. So you can say strong field ligand forms low spin complex and weak field ligand forms high spin complex. So if you are getting this logic, then on the basis of this logic, what we can do, if any MCQs comes, it will be very easy for us to solve this. For example, I have given the list of these MCQs and the type of the questions that they ask. These are the following complex, student, and to this following complex, we all have to solve these questions. So first one, I am just trying to solve it for you. Say for example, the complex which is given, they are asking oxidation number of the metal, electronic configuration, coordination number, ligands, its type, hybridization, and the type of the complex. So this complex is MnF6 3-. It is called as hexafluorido manganate 3 ion. Oxidation state, if you calculate for manganese, so it is, student, it is +3. In +3, the configuration of manganese will be, it is 3d4. Please remember, if it is d4, so let us go back and please check that if it is d4, so it is following the second part. Second part for d4, if it is strong field ligand, it will follow these sequence, and if it is weak field ligand, so it is going to follow these sequence. So if you will check this, student, the ligand is what? What is this ligand? This ligand is, the coordination number is 6 first. Ligand is F minus. F minus is what? Weak field ligand. So what is the sequence for the weak field ligand, student? For weak field ligand, if you'll see, the hybridization should be sp3d2. See, so the hybridization here, it should be sp3d2, and since outer d is involved for the hybridization, this complex will be outer orbital complex. Now let us try to solve this. Second one, manganese, it is hexacyanide manganate 3 ions. If it is oxidation state is +3 in this case, again the configuration will be 3d4. Coordination number is 6 over here, and here the ligand is Cn and it is strong field ligand. So for strong field ligand, if you check the sequence, it is D2sp3 hybridization and it is low spin complex. So strong field ligand, it will be D2sp3 complex, the inner d orbital involved, that's why it is referred as inner orbital complex. So by using these logic, student, we all can solve. So these are the following questions that you all have to solve. Only the thing that you have to remember, in the last example, generally the oxalato is weak field ligand, but this is the only exceptional case where oxalato with cobalt is acting as strong field ligand. I repeat, oxalato is weak field ligand, but with cobalt it is acting as strong field ligand. So it is the exceptional case which is given in NCERT. So we are expecting you to solve all this, and if you are not getting, then we will discuss into what doubt solving lectures.